I've got this neat little demonstration piece or educational aid. Um, it is a MEMS device, which is micro electromechanical systems. Um, this is a gyroscope. It's used for measuring velocity, or at least this is a very large representation of one, right? This is something that would be very, very small on an integrated circuit on a circuit board. Um, and so I didn't design this. This is just something I found online, and it's just very, very, very neat piece because we've got this thing right here called a proof mass, and you can see, right, these guys are springs, and we can see how this changes, right? These plates here, I'm kind of going on a tangent, but these plates here are variable capacitors essentially. And so based on the way this moves, right, this will get varying capacitances, and that might be part of some sort of resonance circuit, and you can get a frequency, and that will tell us some component of our velocity, angular velocity, excuse me. Anyways, that's all fine and dandy, but the more interesting part here, at least for the context of this video, is this little spring right here. And what's interesting about it, and it's kind of hard for me to show you in the video, is this is almost exactly one deposition width for the 3D printer, right? It's just a single one pass. So I believe when I downloaded this, there were some instructions on how to slice and print this, because the reality is it is possible for you to design parts that you say, I need it to be this wide, but if your 3D printer can't achieve that width, the slicer will, in most cases, make it bigger, right? It'll just say, okay, well, I'm just going to color it in and make it as small as I possibly can. Or in some cases, that geometry will be occluded, right? It depends on what the slicer parameters are. But anyways, it is something to be considered of, right? Is how small can you actually go, and what is manufacturable, right? Because the other thing is, right, these distances along these depositions are also kind of a key thing, because you can only have so small of a hole. In fact, this is another tangent, but I remember just being exposed to a project that some fellow researchers were doing when I was doing my PhD, where they were trying to make these things called slot dies using a 3D printer. Slot dies are very expensive. You have a syringe on them, and you're depositing a very thin, wide stream of material. Anyways, and they were trying to get a slot that was very, 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 very thin, right? That was 3D printed. And it's a hard thing, because if you push this distance too small, what is eventually going to happen, or what could happen if your printer isn't tuned in fine enough, is it'll just stick together, and that hole will almost not be visible. In some cases that's a problem. In some cases you can just take a razor and just go through and post process it. But it is something to be aware of.